Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Muhammad bin Saleh from UTS Pago Johor. I am from Section 3 Computer Architecture. So today I am going to tell you about instruction set and how to use RISC simulator. As we all know that CPU is a device that processes data given, but not only the data going inside the CPU. The CPU also need the instruction set that give commands or instructions to the CPU in order to make the CPU know what to do, and the instructions being read in machine language, which is in zeros and one. The command also different on different type of CPU. So there are two types of instruction set, which is CISC, that stands for Complex Instruction Set Computer, that used to calculate the complex operation or calculation, and RISC stands for Reduced Instruction Set Computer, that used to calculate the basic operation or calculation. So today I will explain how RISC do his job inside the CPU. For my project, we've been given a C programming and need to convert it into a assembly language, and we use the RISC simulator to explain the process that happen inside the CPU. So this is the C programming language that we've been given. So assume that I have 8 pieces of cookies, then I give to my brother 3 pieces. Then my mother gave me 2 more pieces of cookies. So the question is, how many cookies do I have now? So this question is based on set B. So first thing first, if you open up your RISC simulator, you will see the interface like this. On the left side of the simulator, you will see the assembly language, where you need to put in your specific code that you wanted. If you don't know about assembly language, I suggest you click on select and click add, and you will see the example of assembly language. Now, I will start the program and I will click the start button to explain their movement one by one. Okay, so first thing first, the register will release the first program counter or PC, which is start from 0. This program counter 0, start from 0. Okay, there we go here. Then the PC will find the address inside the main memory. This is the 0, the specific address. After get the specific address, the address will go to the instruction register, which is over here, instruction register, where the address bring the specific instructions need to be done by the CPU. This is the instruction need to be done by the CPU. I will play it. Okay, so now for this case, program counter 0 and 1 will need user to put 2 numbers in order to perform this instruction, which is input. Then the first number will be stored at register which is R0, and the second number will be stored at R1. Program counter 1 also face the same process. So I will put the number, which is 8, and we store to R0. So now this is the program counter 1. It will meet the same process as program counter 0. You will fetch the instruction, then go to instruction register and need to put input also. So 3, and we store to the register at R1. Next, on program counter 2, the same process will be continued, which is the address we fetch from the memory and go to the instruction register. Okay, so I go to click step. The same process will be faced. The instruction will be go to the instruction register. Then there is a specific command for subtract. Then the result will be stored at R4, which is over here on the assembly language that I put. store at R4, R0 and R1, which is subtract or minus. So the number will be minus is 8 and 3. We can see right here. 8 and 3 go to the arithmetic and logic unit, which is ALU, where the calculation happens, and then the result will be stored at register R4. Then program counter 3 will face the same process like PC0 and 1. You see, the 8 and 3 will be minus on the ALU, then the number will go up at R4. Okay, as I said earlier, program counter 3 will face the same process like PC1 and PC0. The instruction fetch, then I will need to input the number, which is 2. Then the number will store at register R3, 2. Actually, we can store anywhere that we want. We can store at R2 or R1 or R0. It is basically on your coding. Then, on program counter 4, the same process will still goes on, which is fetch the address and get the instruction into the instruction register. This is where the addition calculation will be calculated with 2 that I put in an assembly language. I put add R4, the place result, R4, the last result, plus the R3, which is 2. So I will click step. As you can see, the same process will still goes on. Fetch instruction, brings the instruction, and bring 5 and 2, which is this is 5 is the last or previous result, and this is the number 2, the previous input. So for your information, 6 over here is for addition, and 1 2 3 is the address for the in the main memory. So the number will still goes on the ALU, and we will add it. See right here, will be added, and the result will be 7, and will be stored at R4, the new result for R4. So lastly, the same process will still goes on, which is the fetch instruction, and goes to the instruction register on program counter 5. So we'll click step. Same process will still goes on. Fetch the instruction. I will speed it up a little bit. Then will be the specific instruction, which is output for R4. So this is the R4, the output is 7, and will be placed on the screen, display on the screen. So we'll click play, but there is no output. Maybe there is a bug. I don't know, maybe I try way too much. I don't know. I'm sorry about that. So then the last program counter, which is PC6, comes up from the register, and then we'll go to the 6 over here, which is he brings 0 instruction. Then we go to the IR, then the program will be halt. Okay, so I hope you guys understand what I'm trying to explain, and I hope you guys know how to use assembly language in RISC simulator. So that's all from me. So don't forget to subscribe and like my video. So thank you guys.